Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. And I say that every time to get me in the mood to actually talk. Because before the streams, I just sit here and stare at the screen for 5 or 10 minutes, depending on how early I am getting set up. It helps me. Anyway, I called this episode Ping Pong. Last week was Flip Flop, this week was Ping Pong. I actually got those mixed up when I uploaded the video, I think. But today I wanted to, I woke up this morning actually forgetting that it was Sunday. And a few hours ago, I realized, oh, hey, I need to stream today. I wonder what I'm going to do on the stream. So I thought about it a little bit while I was making dinner, and I thought, well, one thing that's pretty cool is those little games people make on shadertoy. Now, I've seen Bubble Bobble on there. I've seen Pac-Man. I've seen a couple others. And I haven't really looked at the code for how those work, but I figure, well, it has multipass, so it must just be storing the state in a couple textures. I wonder what that would be like doing in this tool. So I think that's what we're going to do today. We're just going to keep it simple by making a basic sort of Pong clone. So we're going to start by just making a ball bounce around. And then slowly add things like paddles, maybe scores, just see how far we get. But I think that'll be fun. And kind of a interesting use case for GPUs. So I think that'll be cool. By the way, hi to guys in the chat. Chat is overflowing already. Driven, Def Pram, Alkama, John Hunter. Daniel Collin, Dark Second, Zamok83, Love Like Semtex. There's a name I haven't seen in a while. Metal Voids. Sorokia, hey, how's it going, man? Cries. Cool, good to see you guys. Cries, yeah, maybe some crazy lighting effects. Cool. All right, so this is the thing I made last week. So the first thing I'm going to do is basically clear out everything. So this will be fun. Yeah, Drift working on his BSc due Tuesday. And yet here he is. That's funny. But honestly, good luck with that, man. So I basically cleared everything out, but I'm leaving some stuff here. Basically what I have is this profiling thing, which will measure the whole frame. And then I have a bunch of stuff here, like here, this will clear the screen. In fact, I can clear it to a different color, for example, which does not work because we're calling a function that doesn't exist. Yeah, there we go. And not very exciting. But then the stuff I have here just basically changes the width and height variables to match a given aspect ratio that I give it. I actually want it to be 1 by 1 today because I want to do just a square. And that should basically be everything. So now we have to set up a couple things. In particular, we need a render target that's actually going to store our main game state. So I'm going to figure out which key I hit to do render targets because I don't remember. Here's a render target. We're going to call that state target. Driven, that sounds cool. Good strat. Nice life hack. Okay, so we need width, height, don't need depth. RGBA, let's make the RGB. Actually, we'll leave that because we don't know what we need yet. Yeah, I think we just need a target for that. Now, so normally how I would do this is I would do ping pong buffers. So every time, like, we would have target 0, target 1, and every other frame we'd swap going between those because you can't write back to the same target that you're reading from, at least in a simple situation like this. So what I think I'm going to do, I can't really, like, I don't have any persistent state between frames other than the contents of the render targets in this system. So I'm actually just going to render from one buffer to another and then just blit back to the state buffer again, and then probably render everything out of that state buffer. So we should have basically a state update that we do and then rendering. And that should be it. Should be the only two paths. There's state and then blit back to the state and then render. So it should be about it. So that's what we're going to do. Make a couple other targets for this. Again, if I remember the key to hit. State target, we're going to do state blit target, or we can do state prime target, we'll call that. So we're going to render from the state target into state prime target, then we're going to blit back to the state target, and then we shouldn't need any other targets actually, because we can just blit the result to the screen. So it should actually work. I'll comment, he deleted DOF in Chrome app, checks Ferris temperature. Thanks for looking out for me, man. I did actually consider leaving all that in there, because we could just like dump post effects on the game when it was done. But probably best if we don't do that. So yeah, I think this is all we need. We can just say initial state is black, and we can figure out what that means later. So then, now that we have the render targets, I'm actually going to set up a couple subroutines here. I know it's hard to read because the stuff is small, but just bear with me here. So this, I just created a subroutine and a call to that subroutine, so we're going to call this init render targets. There's your subroutine here, and we're just going to call that here. Actually, I'll even just split this up into even more stuff here. I'm going to make a function that's game frame. We're going to call that. Oops, that's an argument. I wanted a call to it. I'm going to call game frame. Game frame will call render targets. Cool. I don't really know how I want this stuff set up yet, so just going to make a mess here. And then, yeah, game frame inner render targets. Then we need update state. Another thing we need. Call this here, and then we'll create another one, which is going to be blit state, because we're going to blit that back to the buffer. A lot of stuff to get through before all this will make sense, but it should work in the end. And then we'll render. So yeah, so game frame is just going to call these things in a render target, and then update, blit, and render. Yeah. Nice and easy. I think... By the way, sorry if there's extra background noise. I forgot to do dishes until recently, so my dishwasher's running. Need to think about this for a sec. Why don't I read the chat? That'll help. Yeah, job market is just very different, because then you have deadlines all the time. And you don't write anything up. Hunter, I just had a dream that my school added a policy that you couldn't make cool new intros, and everyone was horrified. That's a terrifying dream. I still have a lot of like nightmares about missing tests and stuff, and I haven't been in school in many years. Yeah. Right now I can just implement both of these as blitting back and forth if I really just want to have placeholders there. Actually, let's make update state just draw something. And then that'll draw to the blit target, and then we'll draw this back. So something that just updates. I don't know what that'll look like yet. Maybe something that flashes. I don't know. We'll do that, and then we'll render the stuff from the state as well. I think that'll make sense. And if we get some kind of loop of stuff changing, then this will make sense. I might also make a subroutine to do the sort of initial state, and then I might just like hack this to call that and then go back to it. I don't know. We'll figure that out. Anyway, so the update state, that's going to need to bind a render target. So we're going to create a render target binding, which is right here. And we need to bind the state prime target. We're going to bind this one here. And so that means we're basically drawing to it. These have just the same width as our viewport. That's going to be fine. Not going to worry about that yet. So we do that, and then we need to bind a program. In this case, I'm not sure what our vert and frag are going to look like. We're just going to make some simple, I don't know, something that draws stuff. Hey, Evil, how's it going? John Hunter says the frame takes one millisecond. Like, what's it doing? It it'll just have a bunch of variance, which mainly comes down to the fact that the way that I'm doing the timing isn't as fine-grained as it could be. You'll notice also it's bouncing around, so like it starts a little bit off of where my start time is. Not anything to worry about. Yeah, I think so. Normally the program will just use this test.vert and test.frag, which have some like matrix stuff. We're gonna make that even simpler. Just gonna copy these out to new files here. We can call this stateupdate.vert. Actually, I'm gonna rename that to include the word pong. And then we're gonna basically do the same with frag here. Oh, whoops. I just totally put these in the wrong directory, didn't I? Or did I? No, that went where it needed to go. Yeah. Just going to make main do something simple first. We need actually this out thing here. Whoops. Need our frag color. And we're just going to vec3, so we're just going to make it red. Excuse me. Because we need to be able to just see that this is working first, so almost always just do that. I will take in the vertex position. We still need that. Shouldn't need anything else, actually. Yeah, because we can basically just take we can do this. Our sort of simplest setup here. Now at that point, this should actually be working. If we don't bind this target, we should be able to draw stuff here. We need a quad. I totally lost my key map here, but this is fine. Yeah, and then we need to hook this up. So to actually use these shaders here. And that, I expected that to work, but it didn't. Let's look into why. Oh, where's my terminal? Here's my terminal. It's not finding the files. Oh, I called it Pong state update, of course. Okay, that should update. There we go. All right, so that's what we wanted. So right now our state update's just outputting red, but this is exactly what we expected. So now we're just gonna output red to this this buffer here. So not too bad. Next we're gonna basically blit that, but I'm just gonna blit to the screen for now, because that'll make it a little bit easier. And then we'll make it blit into that render target again. Yeah, so I'll actually get rid of this. Program is what I wanted. I don't have copy and paste for nodes in this yet, and I really need it. Or operators, that is. But that's fine. Pong state blit. I think I actually have. I think if I just do quad, and there's already a blit.frag. Let me look in here, because I think I actually have this stuff laying around for these purposes. Maybe I don't. This I do, and it even has this little text chords thing. Let's actually use this quad instead of the state update.vert here to reduce files. It'll still be compatible as far as I know if we don't need the that other parameter that it outputs. Should still be fine. That should just be stripped away during linking. So that'll be good. And then, yeah. For now, we can just grab the same thing here. Call this pong state blitz.frag. Now this is actually going to need to take the texture from this render target. So we're going to do a couple things. First of all, we need to actually bind that thing. So there's this uniform render target texture, which will take this as the name. So we need the name of the render target, and we need the name of the variable, which I'm just going to call text. And then the index on the render target, which is going to be 0, and the route mode is clamp. That looks fine. And then in the shader, we need a uniform sampler 2D text. And what else do we need? I think we need the resolution as well in order to actually read the right pixel here. It's basically going to do sample text, or sorry, this is a texture. And then a vec2, which is our UV. And we take like GL frag chord.xy divided by resolution, which we're going to need to pass that in. I actually don't have vec2 support in the CPU code in this stuff, so I'm just going to pass that as two uniform floats, which will be fine. So we're going to do res is resolution x, resolution y. And we're going to take those in as well. So uniform float resolution x and y. And now we need to specify those here as well. So we're going to do some uniform floats. Resolution x is going to be width, which is where I keep that variable usually. And resolution y is going to be height. UX is coding in reverse. Not entirely sure what that means. And not getting any errors, but we're not seeing anything either. Not entirely sure why that is. Oh yeah, we're not calling blitz state. Now we're still not working. Okay, now we have a shader compile error, which is fine. Yeah, here. We need X, Y, Z here. Now we're getting some other GL error, which is odd. Stuff is always finicky to set up, but you know. Aphis is going from down to up, yeah. Not actually sure where these are coming from. Just don't need this yet either. Oh yeah, we actually need, first of all, this needs to be, okay, we did get the right target there actually. State prime target, and that's where this renders to, okay. Resolution X and Y. And the text. Not entirely sure where that's coming from. We can also use these text chords to look up the texture if we would take that in here, but that, I don't actually want to do that. It's fine for the blit actually. Like, let's do that because we can. It's actually nicer because we don't need this stuff. But I don't want to do that later. However, I'm not sure why this isn't working and why we're getting GL invalid value. I've seen that happen a couple times with the tool. It may actually be something buggy. So I'm actually going to restart this. We'll see what happens. Okay, we're still getting it, which means we're doing something wrong here. Oh. Got some red there for a second, but I think that was a fluke. What is going wrong here? I can't imagine it to be something silly like this. But I've seen weirder things. Leave that there just in case. Yeah, we're still getting these. Not entirely sure. Although I did just notice we need to set the viewport when we actually render to these. Driven to what code editor do you use? Right now I'm using Sublime. I'm going to set up the viewport here. Although I don't think that's the problem. Okay, that actually helped. Which actually can make sense, just because of... Actually, that would make sense why we saw red there earlier as well. Because we need to render to this render target, but this viewport here actually sets the viewport to basically center the... center everything within this quad, given the ideal aspect. So it basically figures out, given the aspect ratio and the current width and height of the actual viewport, it'll figure out like the offset here. And then when we bind this render target, we actually need to set the viewport to... something that'll draw on here instead. So that actually makes sense that happened like that. And the viewport works on a stack as well. So when we get into this stack, we're going to get this viewport here. But why we're getting the invalid values from GL, I'm not entirely sure. So that's a bit weird. But I'm actually just going to keep going. Because it doesn't really matter for a simple test like this. Okay, so now we have the state being updated into state prime target, and then that's then being blitted to the screen. However, instead of blitting that to the screen, we're actually going to bind... we want to write out to this other render target, so we get this sort of ping pong thing here. Instead of state prime target, this could be state target. So now we should have this going back and forth. And I'll figure out a way to test that in a minute, but then we can do a render pass as well. And for that, we're going to bind one of the textures here. In this case, we'll do actually the state target. So we'll do text, not state prime, but the state target. And yeah, should be good there. And then we'll just bind a program here. Quad, we can call this pong render. And I think that should be it. I think we'll also need, we need to draw the quad here. And we're going to also need those other variables for resolution. In order to see, the reason why we need resolution here is we're basically going to be storing different states for the game into different pixels of the texture, and I need to figure out which pixel we're on in the shader to figure out, which piece of the state we're going to update. And I'm actually just going to do that by comparing the pixel positions, and that should be fine. Dark second, shouldn't update state get state target bound then as a uniform? Yes, it actually should. That's actually why we did all that. Yeah, you're absolutely right. I think... Yeah, we'll just do this here. actually gonna call this state text here. I like to name these something sensible. So a couple things with that. We need the in state update. We need uniform sampler 2D state text here. We're also going to we're gonna do the render thing here as well. Pong render. Also gonna take the state text. I don't want to use this here. And we should be okay. Yeah, then we also need our resolution here. Also, this needs to be the right viewport. Okay. We need the blit to actually read this, which it still is. And then render. The easiest thing we can do is something like this. So like we can just render out the state texture, for example. That's going to be like that. Oh, yeah, we need to call render as well. And I'm getting some errors again, which is likely the same bug we had before. Okay, then we get red. That's looking good. Let's take the state update and we're gonna make it output pink. And it looks like that's still working. And then the blit, since it renders out of the state, because it showed the right color, we know that our little loop there is working, so that's nice. We can do something like make it blue, and then yeah. So now we have hopefully everything set up here. Dark second. So first of all, this isn't shadertoy; it's my tool, but you do need to blit in that case as well, because it's a limitation on GL that you can't render to the same target you're reading from. It's not a limitation of the system, so it's going to have the same issue there. And I'm pretty sure they do it the same because they also have multiple passes. So I'm pretty sure that the guys that are doing this kind of thing just do this same structure here. So there we have everything set up more or less here. And now we actually want to stuff some state in this thing. So I want to state update. Let's just output black for now. Good. And then, yeah, let's actually just have, we could just create the ball, I guess. Let's also do some constants. So we need to know like the size of the ball and everything in order to draw it. So one thing we can do here is, because the system has include statements for shaders, we can do stuff like put these constants in there. So we can do things like let me see. Yeah, we'll just do, I think, const. We'll do ball size. And that'll be, I don't know, 10 pixels wide. And we're going to do this. We can say pong common.frag. Actually, I want to rename that .glsl. So that should be fine. And then in our render, well, let me move some windows down here. There's this. Okay. And then in render, we're going to include that. And now we can use that, for example. So we can say, we're just going to hack that the ball position is in the center, which right now it isn't, but it could be, for example. And then we basically want to render this, like, I think I'll just render it as a square. We'll just say all of the pixels that are within where the ball is are going to be white, and then all the other ones are not. So it shouldn't be too bad. John Hunter 9 says, what does everyone think on the subject of 8-clang? I hadn't actually heard about 8-clang. But I guess it's a 8K specific version of 4-clang. I'm still not really sold on the whole 8K concept myself, because it just seems like a weird in-between category. Like 4K is about doing one or two things just like really, really well. And then 64K is about like putting a lot of like high quality content in there. 8K just seems like the best at nothing, I think, is how Garguy put it, and I really agree with that. At least right now, like there's no, I'm struggling to think of a lot of like genre defining 8Ks that really make sense for that space. I can think of a couple. I remember there was an 8K at Tursock that I really, really liked, but yeah, I don't know. Not really convinced myself. We'll see what happens. Metavoid says 256 bytes. I like the 256 byte intros. Evil says 8K for people not being able to make it in 4K. That's kind of what I see most 8Ks like right now. Like, let's just do everything we do in 4K, but we'll have a little bit more sync and maybe another scene or two. And it's like, okay. Would have been cooler as a 4K. Like I said, there were a couple 8Ks that I liked, but the genre really, I don't know, needs some time to mature, I think. It's not there yet. So let's render this ball. Okay. So this is actually really easy because we can do like vec2 pixel position. If we just say our coordinate system starts at bottom left, we can just do this. In fact, we're not actually going to read from the state text right now, so we can just do this. Let's do vec3 color is black. Make it actually dark gray so that we can actually see some background here. And then we'll take the pixel position and the ball position. I'm actually going to rearrange these a little bit, keep it cleaner in my head. And then we're going to say something like we have the position of the ball, so we can say if ball, sorry, let's do, and we have, yeah, ball size from here. If pixel position is greater than or equal to the ball position minus ball size over 2. Do this. We're just going to write this out in kind of a crappy way, and that's going to be okay. Also, I've been writing a lot of Rust this weekend, so I forgot about parens. Oops. This here. And then we'll do, so if we're basically within the range, or if our pixel is within where the ball should be, then we're just going to say the color is white. And I'm not sure why that didn't work. We should let me do this really quick. Okay. Are we setting the resolution for this pass? We are. Making sure this is giving me what I expect it to give me. This is a problem with little things like this, is they can be kind of finicky to set up, but when we get the ball rolling, so to speak, it shouldn't be that bad. Strange. Also, you notice I've defined the ball position to be in the middle of the ball, which I hope will make things a little simpler later, but we'll see. It might not. But why didn't it like this? It looks like for this to happen, pixel position is basically like way out of range. Not really sure why that would be. I actually saw something fly by on my console. It was not related. Somehow these values are just enormous, which I'm used to for like this stuff. I'm actually wondering, because I guess GL frag chord is relative to here, so it would probably make sense if this had to be like the full screen resolution in order to make it the square we had in mind. We either need to change the viewports that we're only drawing to like the left corner. And I'm used to doing it this way usually because I'm drawing to render targets. But it's probably the case that we actually need to, instead of taking GL frag chord and scaling it down, we'll probably need to take the text chords from the vertex shader and scale them up instead, which is fine. So we'll just take this in. And our pixel position can be this times the resolution. And then this still didn't give me what I wanted. So text chords, as far as I know, goes from 0 to 1, which is what this remapping here is doing. And that's fine. Let me get the vertex position here. Oh yeah, we don't need to divide by res. Actually, we would want to. It's gonna be text chords. Let me just output these just to be sure. Okay, so this is what I expect from the text chords. If we multiply that by res, we're not getting a very nice number there. Now I'm wondering if that's actually, if our resolution's wrong. Evlac today, Pong tomorrow, Arkanoid. Yeah, if today Pong even goes well. Oh, you know what? This was really dumb, guys. This was really dumb. I'm totally setting these uniforms outside of binding the programs. Don't be like me, guys. Don't do anything I say or do on this show. ever. Yeah, and now my now my GL invalid values stopped flowing. So that's actually totally why. Whoops. Okay. Anyway. Nice. So if I multiply this by res, we should get white, and then if I divide that by res, we should get exactly what we wanted. So this is actually good. Now if I do this, we should see the ball. Bam. Okay. Okay, dumb mistake. It's all right. Now we get the ball. So now what we can do is we can actually read this ball position from the state texture. And we can do that just by like reading a specific pixel. So if we do something like this, let's do const vec2 ball position pixel. And we'll just make that 0. So we're going to be the 0, 0 pixel. Dark second worked the first time. It did. Before the stream. As if I were organized enough to actually try this stuff before doing it. Okay, so we'll just mark this as the original ball position. And then what we can do is read that specifically. So now instead of the ball position being res over 2, we can actually read that. Now I'm thinking we could either do all the coordinates normalized, or I can just make the state texture a 32-bit float texture, which is going to be easier. So I think I'll do that. Hunter, whoops. It's Ferris's Ferris's fetch phrase. So we can just do texture with the state text and the ball position pixel. Let's do ball position UV. I think that feels better to me to write it that way. Now we're getting, yeah, we need just the XY out of this. Now it's on the bottom left, which is good because that means that pixel should have been black in our state texture. So that's what that should give us. Now, if I... Okay, so what we need to do is we need to make the state texture and this other blit target because they need to be the same format. We're going to make these RGB 32F and A just because who needs video memory, right? And that'll be fine. And then, okay, so now we have this update loop that's going between these two 32-bit float textures. And we know that the first pixel should be something. So on the state update, what I'm going to do is I'm going to include this stuff. And this will be pretty easy. We're going to do vec3 color is this. And we're going to do some other stuff. We're going to need the resolution here as well. Actually, we do need this. Yeah. So we're going to feed the resolution into this pass as well. I've never done any shader programming. Saving state and textures like this, it seems like black magic. Yeah, no, it's a weird thing to do, but it's kind of a fun thing to do. This is definitely not best practices. This is based on some hacky stuff I keep seeing on shadertoy that I thought looked kind of neat. So. Now, granted, it actually makes a lot of sense to do some kind of state and textures like this. Like doing particle systems is really popular like this. Like you can have ping pong buffers for the positions and the velocities, for example. That works out really well. It's very, very parallelizable. But the way we're doing it like this is crap. But it should work, so that's fine. So yeah, so we have this color here, and we're going to output the color, just like we do with the render pass. And what I'm going to do is we need to get the res and pixel pause like this as well. And we're just going to say if we're even going to do equality on two 32-bit float values. No worries. Then we're going to do the update for the actual ball position. Driven says, reminds me of that GIF I saw of a guy programming "Hello World" in C by drawing pixels to specific colors in Paint, saving his bitmap and renaming to C. I recall IQ doing something like that. Maybe that was him. Capital GIF, yes, I am good at right. Tell me about it. So what we can do is we can read the original ball position, which is going to be, the text chords. So the nice thing is we know, basically with this, we can just read the current pixel, and that'll give us what we need. So we'll do the same thing here. Actually, let's just read these out anyway. So we have the ball position. So if our pixel is the ball position, then we're going to make a new ball position. For now, I think I'm just going to make it stay in bounds, and then we'll make another thing with... This will make sense. Just take me a minute to set up. But I'm just going to limit the ball position for now. Actually, less than ball size over 2. Actually, not else if. And I don't need all these here. Make this shorter. And we'll do the same thing with like this. And then we say the color is vec3 Now I expected that to bump up the ball a little bit, yet it did not. Not sure why. It's probably this. Actually, that should be okay. Just to be sure, that would have a little bit more precision, but I don't think that's the problem here. We could also do this, by the way, just to test. It's going to be res... Actually, I'll do res 5x2. This should place it in the middle. Just comment this out. Oh, whoops. Our blit pass is still multiplying it by blue, which totally clears out those values. Didn't help, but that's that's not good that was happening. Those are the exact values we're trying to update. Read the ball position. It's not this conditional. Just to be sure it's not a precision thing. Okay, so it actually was. Okay, so this is a precision thing. So we need a different way to do it than actually comparing this with equals here. Yeah, because this way now it's just writing 0 to everything. So what we need to do then is we can do something like this. Or distance between the pixel position and the ball position is less than some threshold. And that should have worked. What's our tolerance here? I suppose that makes sense. In fact, actually, now that I think about it, I'm pretty sure GL... Actually, yeah, this makes a lot of sense. I think GL centers pixels around like halfway across the texel. So I think actually we need to do this if we're going to do this. And then this here is something like that. Oh yeah, that's 0.5 is way too high. It's because we need the resolution divided by 2 here. Because I'm worried about just using this pattern because it'll mess up with our other. Yeah, it won't play nice. All comments is GPU dependence. I don't think it is, although we could use texel fetch for some of this stuff. But I don't think that helps us with writing. Let me look this up, actually. Yeah, so I'm saying just after quick Google that it's always the integer position of the pixel plus 0.5. And that I think that's fine. So then we need to do, we'll do like half pixel here. By the way, this shouldn't matter now. If we take this, divide it by 2. I think that works. Not liking something. Oh yeah. I think by the way, hey Huffman. Because I think ideally we'd get something like this, but I don't think this will work. I think we actually do need to do some thresholds here. And yeah, I think using texel fetch here would be better for actually reading these values. But, let's just do this. Let's just do, just for the sake of hacking this together. We don't actually have to do it properly. This. I'm not really convinced with what I'm doing here, to be honest. I might actually do texel fetch for this just to make it, just to remove variables. I think I will do that actually. So for that we can do, we need half pixel in like both scenarios. So we'll do this here. So let me think of this as well. So 1 over res divided by 2 is the same as times 1 divided by 2. And then we multiply both by or res. That's the same as res times 2. And if we divide, okay, yeah. So I did have this right where I just wanted it to be 0.5 over 2. Just checking. And we're gonna do plus half pixel here. Oh yeah, we actually don't need that now if we're doing the, not thinking straight here, but we should be fine here because we're going to turn these into texel fetch calls instead. So texel fetch works the same as just texture, although we need this to be an IVEC 2 because we need to specify integer coordinates, which is better in this case anyway. And then we also need to specify a level of detail value, which is fine. Which I think is an integer, yeah. So design, hey, how's it going? Yeah, we're doing making Pong in just a couple shaders and some textures. Hacky as hell, but should be fun. Here. Yeah, so now we're getting some undefined half pixel stuff, which is in Pong state update, which is here. Yeah, so just want to break this again. And now I want to do this. Okay, now it works. Just do everything in integers, use texel fetch, do things right, stuff is easier. Okay, so now in this case, now I can do this limiting thing. Although, yeah, now this should put it back in the corner. But it should actually be offset here, so I'm not really sure why that didn't work. I wonder if we're not reading it correctly now. Which would be annoying. Fetch. Oh, yeah. Yeah, thanks, Dark Second. Need to dump that to color. There we go. That's exactly what I expected. That's what I was going for this whole time. It was just to offset it like that. So now we have our state loop working. We are actually somewhat colliding against the walls. Now I want to move the ball. The reason I didn't want to start moving the ball earlier is because I didn't want to move the ball earlier because I knew it would just fly off the screen and then we'd have to get it back somehow. So I wanted to just like do this simpler first. Now that that's working, now we can do velocity as well. So what I want to do is just start enumerating these. I'm actually going to write these out in here because that'll make it a little bit easier. So now instead of the ball pause, we'll call this ball vel, which is going to be the velocity here. And this should actually be really simple because we're going to do this. So it's going to be reading the ball velocity. So it should just be like this. I'm also going to hard code the ball velocity here just to see it move. And now we have state updates. Bam. How cool is that, guys? Now it's working. Now we're rolling. So this should, if I put this back and save it, it should actually move all the way up and just hit the top and then stick there. Bloop. Yep, good. So our collision's working. So now we're rolling. Now stuff gets easier. Okay. This stream brought to you by this barcode. Sorry. Yeah, so now we want to actually affect the velocity, so we're going to actually make the ball bounce around. And the nice part about this actually is that we don't actually have to do integer stuff here. We can get all kinds of fun velocities if we want. It's not a problem. So I'm just going to leave this as is. Whoops. Because we also need to update the velocity, by the way. If pixel position is equal to the ball velocity, there we go. And now I don't need to do the ball velocity here. And now when I do this down here, things will move. I'm giving it kind of a weird velocity on purpose because I want it to hit the walls and start bouncing around more interestingly than just getting stuck between the two corners. Metal Voids, do a barcode generator in GLSL. That would not be a very exciting thing to make, actually. Just do a hash. I mean, I wouldn't generate actual barcodes if I did in GLSL. That's the thing. Could, though. But anyway. Yeah, so when the X position is less than here. So actually, we need to detect these same collisions down here. And I'm just going to copy them. Because why not? Actually, we can just do this. I think this actually gets a little simpler. Now let's see if this bounces around. Let's pick it up. Or go a little faster. That didn't work. I wonder why it's not bouncing. It could be this, that we want to do something like this. DSP on GPU is pretty cool. It takes a lot of data moving to set it up, though. I don't think it's hard-coded. I think it just reads it up here. And I keep commenting this out and saving it, so it shouldn't be a problem there. We may want to do this, though, where we kind of separate these. Like where we also check the velocity. Boy, does this kind of logic take me back. So like we only negate the velocities if the velocity was pointing at that wall. Or being a kid and always having issues with that. Help at all? Does not help. Interesting. Why is that? This is working because we're able to set it here. We are outputting the velocity because we're definitely controlling it from this, because otherwise this wouldn't work. This would have to... So we're definitely outputting the velocity. This is definitely going to be different as well. Because we're only going to do one or the other. We definitely output the velocity here. So why does this not work? Yeah, this ball does not want to bounce. Let's just do this. And I think that worked. Yeah, it's exactly 8 dark seconds because I limit the positions here. So that should work. Now we're bouncing. I'll take it. We can also do fun stuff in here, like increase the size of the ball, and it should just be okay with that. So that's pretty cool. Worst pong ever. But it's our worst pong ever. Oh, yeah. Okay, so what happened there, by the way, is I resized this. And in this system, when it resizes the render targets, it reallocates the storage. So everything got reset to 0. So we need some like initial values. Hummergans, witness, I'm going on an expedition to find all those ET games buried in the desert. That's awesome. I love that story. I'm going to do an initial state pass, because that'll help. What is that? Oh, yeah, plus equals. Yeah, that makes sense. Here we're going to do res over 2. And for the velocity, we'll just do something simple, like something like that. Yes, that's the initial state pass, and it has all the same inputs as this. So let's go ahead and make that. Now, this is something we're not going to want to call all the time. But we'll need it to reset stuff. So that'll be fine. Pong state update. We're going to do the same stuff here with binding the render target. Oh, you'll notice these get marked red when I'm doing stuff wrong or haven't hooked something up. That's actually the compiler telling me errors and telling me, yeah, what's actually wrong there, which is pretty nice. Oh, yeah, actually, we totally don't need the input state text for this. In fact, we shouldn't have it. That'll help. And then we can set the viewport and draw quad. There's our initial state. Otherwise, it should just move. Nice. There we go. So I can do things like resize this as long as I reset the state. Cool. Mad Moose says, clearly the reason it won't bounce is that your ball is, if you look closely, actually a square. Driven petition to make the ball wobble when it changes direction. That's actually kind of a cool idea. How could we do that? Let's do this. that should have worked. Oh yeah. Where is it? Here. Yeah, we can do a different XY wobble. We'll start with just this though, because I already have it hooked up. And the easiest way to do this like that. And then our render, okay, this doesn't actually wobble, but it should at least show us that that variable's changing. So that's nice. But we don't want this to do that. We want it to wobble. So how do I want to do this? We need time. Oh yeah, whoops. Time doesn't move unless I am moving the time in the sync tracker. So I guess I just gotta let that keep going. I think that's fine. That might cause us some problems later, but we'll see. Actually, I wonder... Let's actually just make a time thing here. That's gonna make a lot of this easier. We can just make it an increasing value over time. So we'll get rid of this time. That time's crap. That's sync tracker time, and that's not the kind of time we want. So we'll do... I'm putting this on the corner because that just feels cleaner to me. And it's not really going to matter because we use like constants for all these, so it's going to be okay. I call that time pause? That's stupid. Okay, good, I didn't. Okay. Pretend it's 60 FPS. It's probably a lot more, actually, but that'll be fine. Okay. Okay, now why doesn't this go nuts? That's why. Now I have time. That's what I expected to see. Now I got some wobble. uh, cutting edge tech. Oh, it is. It is. All right, so we can do X and Y wobble here. Let's do that next. Duck 3DS and lobsters. Click clack lobster attack. Actually, you know what? Let's actually just do. We don't need different UVs here because we can just use the different components. So that's easier. Let's go ahead and set all this up then. Like that. So there's our initial pass. The update gets pretty simple as well. Make this vec 2 and take XY out of the texture. I mean, you guys are full of ideas. And that's what this needs, is the Amiga Boing Ball texture. Oh, jeez. I should have known this was coming. Good there. And then in the render, we need both components, and we can take bob X, and we'll do the same thing here. And I think that'll just work. Yeah, nice. Evil says, please fix background to 4.3 or 69. That should actually be very easy. There's 4.3. I want it to be 4.3 because that's more retro. We'll pump that wobble speed as well. Offset phase as well. It's all the details. I don't know if I want to make this the Amiga ball, guys. Could hack it, but meh. Oh, wow, it's already 9:30. You know, actually, I think I might put this down for now, and we can pick this up next week. Because this was pretty fun, but didn't get as far as I wanted to today. And I think that's what I'm going to do. I'll come once again we had you diverge. Yeah. No, I think I'll continue this next week, and then we can work on some other stuff. I really want to get the paddles, and I want to get like some kind of full game logic in here, and then we can post it to shit. I think that'll be fun. Anyway, thanks for hanging out, guys, and I'll see you either on Thursday or next week. Oh yeah, really quick thing. PS Enough. I'll link his thing here. He's doing starting a new season of Demo Scene Theater 9000. I don't really know what the new format's going to be, but I'm a guest on there on Wednesday, so need to link that. So yeah, Wednesday, Thursday, and Sunday this week I'll be streaming in some form or another. But that'll be from his channel, not mine. So although I'll probably host it. Anyway, see you guys later.